Hello and welcome to T2, Day 21 of Honors Precalculus. Today we're going to talk about how you can write lines as parametric equations. So this means we're going to parametricize or find the parametrization of a line that goes from point A to point B. And when we say this, we like to make this at time equals 0 and this one's at time equals 1. What it means is that you're going to start by finding a vector that starts at 0 and ends where you want to start, and then this is time equals 0, and then at time equals 1 it's going to be at this point right here, point B. That's time equals 1. So along the way the vector is going to sweep out, like the end point of this vector is going to sweep out this path right here, that purple path. But it starts at time equals 0 right at 3, 6, and it goes to, sorry, negative 2, 3, and it ends at 3, 6. So what that means is, one thing you can write is the vector OA. The vector OA from O to A is negative 2, 3. And the vector from A to B, where you want to start and where you want to go, is the vector 5, 3, right there. So the way you write the equation from O to P, so the line from O to P, is going to be, you start with the vector OA, and then you're going to add a multiple of the vector A to B. So what's going on here is you're going to first add a little bit, and then a little bit more, and a little bit more, and then you're going to end right there. So what does that mean actually? What that means is you're going to write it as the starting vector, so at negative 2, 3. That's the first vector right here that sweeps out this line. And you're adding to it the vector t times 5, 3. 5, 3 is, another way to see it, is the slope of the actual line. So if this is the line we're finding the equation of, the slope of this line is you're going over 5 from negative 2 to 3 and up 3 from 3 to 6. So over 5 and up 3, over 5 and up 3. So what this means is O to P, the line from O to P, is going to be this vector negative 2 plus 5t, comma, 3 plus 3t. And another way to write that is x is going to be negative 2 plus 5t. That's this part right here. Oh, that's not the right highlighter. Right here. And the y coordinate is going to be this right here. So y is equal to 3 plus 3t. The way you can see this is plug in t values. When t is equal to 0, what happens there? You end up with the point negative 2, 3, and that's where you want to start. But when t is equal to 1, what do you end up with? Plug in 1 right there, you get 2 plus 5 is 3, and then you get 3 plus 3 is 6. So the way you do that is you construct this vector where you want to go, and then you're doing a multiple of t of it. And again, we love to start at time equals 0 and end at time equals 1 for these lines. So similarly for this question right here, we're finding a parameterization. So to answer that, we'd love x in terms of t, and we'd love y in terms of t. And the simple interpretation of what we just did is, where do you start? You start at time equals 0 at A. So x is going to start at negative 3 and y is going to start at negative 2. To go from point A to B, like what is the vector from A to B? The vector from negative 3 to 4 is 7. You go 7 in the x, and then negative 2 to 7 is 9. So that's the vector. So what does it mean? You plug in plus 7t and plus 9t. So this 7 is the one that's right there, and this 9 goes right there. The way you can check this is plug in 0. At t equals 0, what happens to this? You end up at the point negative 3, negative 2. And at time equals 1, where are you? You're at the point negative 2 plus 9 is, negative 3 plus 7 is 4. And negative 2 plus 9 is 7. So you start here at time equals 0, and you end up here at time equals 1. So this one's fun. It's saying, find the parameterization of a circle of radius 2 centered at the origin. How do you do this? What does this mean? What this means is, the circle of radius 2 centered at the origin, it's centered here, so it has a radius of 2, so it's going to cross at all these points around like this. Yeah, that's a terrible circle. I got to do a better job of that, right? And there's also a circle draw tool. I should get better at drawing that. So that's what the path we want to go on is. But how many different ways can you ride this circle? Meaning, if this was a circular track, you could run it many different ways. How many ways? Well, you have to have something where it's x in terms of something t and y in terms of something t. And what you might remember is the Cartesian equation, meaning the equation without t for this is going to be x squared plus y squared is equal to 2 squared, which is 4, because this is a circle of radius 2. So x squared plus y squared has to equal 4. So whatever we come up for here has to work here. Whatever we get has to also be true for x squared plus y squared. So I'm just going to show you one of them, which is 2 times cosine of t and 2 times sine of t. You can show that this is actually the same thing. It's a circle of radius 2. The way you can do this is square both of these. If this is true, x squared equals 4 cosine squared t, and y squared is equal to 4 sine squared t, and then you can add them together. So x squared plus y squared is going to be equal to 4 cosine squared t plus 4 sine squared t. You can factor out a 4 from this, and you get this right here. And you might remember that sine squared plus cosine squared is just a fancy way of writing the number 1. So this shows that x squared plus y squared is equal to 1. So what that shows is this travels along this path. Now there are different ways to write it, as I said. So for example, you could say x is equal to 2 sine t, y is equal to 2 cosine t. That'll work. The car will drive differently on that circle. You could also have, for example, x is equal to negative 2 cosine t and y is equal to negative 2 sine t. This math will work for this and this. These are different parameterizations. So just remember, there are many, many ways to drive on a road, so there are many, many ways to write the same Cartesian equation. What I mean by that is the same circle or other equation as a parametric equation. So what about this? Find a parameterization of a circle of radius 5 centered at 3, 2. What does that look like? Well, 3, 2 will be, there's the center, right? It's got a radius of 5, so it goes down 1, 2, 3, 4, 5. It goes back 5, 1, 2, 3, 4, 5. And it goes up 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're connecting these circles right here. So you have these arcs. So that's what you want. And this equation right here, you might remember, is going to be x minus 3 squared plus y minus negative 2 squared is equal to the radius squared. That's the Cartesian equation, but we want the parametric equation. So how do we go about writing that? Well, again, there's different ways, and I'm going to show you the structure, and then we're going to prove it. So this just takes practice. So here is what the answer actually is, and we're kind of going to do this in reverse and see if we can find other answers. If you do this right here, y is equal to 5 cosine t and y is equal to 5 sine t, how can you show that these are the same? We need to show that these are the same and then see if we can come up with other answers. Well, you can do this by isolating cosine up here. So if you do that, you know that x minus 3 is equal to 5 cosine t. So what does that mean? It means that cosine t is equal to x minus 3 over 5. And then similarly, we know that sine t is going to be equal to y, sorry, it's not plus 2, it's going to be sine minus 2 right here, minus 2, my mistake, minus 2. So it's going to be y plus 2 over 5. So what does that mean? We'll square both sides. It means that cosine squared t is equal to x minus 3 over 5 squared. And similarly here, it tells us that sine squared t is equal to y plus 2 over 5 squared. So what that means is you can now add these together. This plus this has to equal this plus this. So if you add these together now, you end up with cosine squared t plus sine squared t is equal to x minus 3 over 5 squared plus y plus 2 over 5 squared. Well, this, as we know, right here is just a fancy form of 1. So 1 is equal to x minus 3 squared over 5 squared. See how I split that? Plus y plus 2, not x, y plus 2 over 5 squared. Multiply both sides by 5 squared, and we end up with the equation that we want. Now, I'm going to leave it to you to think about this, and we'll talk about this in class. How could we modify this without changing the answer? Meaning, this was the answer I gave you here. What are some other solutions that would also give us a circle? One thing you might have noted is when you're doing the parameterization of a circle, it's frequently going to be cosine for one of them and sine for the other. The last thing I'll leave you with is another explanation of what we did above is down below here in the notes for this page.